Okay, the last of the three concepts of acid bases or definitions of acids and bases is the Lewis acid and base. It's the most broad term of an acid and a base that there is. An acid, now it's basically the definition of an acid has changed and broadened. It's a species that accepts an electron pair from another species, and a Lewis base is a species that donates an electron pair. Something that I want to add here that isn't necessarily demonstrated here anyway. A acid is either going to be neutral charge or positive charge. Species. And I'll point these out as we go. I don't think I have any that is positive, but I do have a lot that are negative, that are neutral. The Lewis base can either be neutral, so it's going to be so if it's neutral, you don't automatically know if it's an acid or a base. You kind of have to look at it. Whoops, I can't spell. Or this time it's going to be a negative charge. And there are examples of this. So here's an example here. This is the Lewis base. It tells you that oxygen ion, and you see here it's negatively charged. So because it's negatively charged, I automatically know that it's going to be the base. The Lewis acid is this SO3 compound. And so what happens is all the there are no electron pairs that are here. So oxygen donates its electron pairs to the sulfur. So we're basically looking at the central atom for the lone pairs or not. And it goes to form this complex of SO4 2-. And I got basically this, I'm trying to do this now, is put it down where I got these images from to give them credit. So this is an example problem, okay? So I have carbon dioxide plus hydroxide goes to form hydrogen carbonate ion, okay? So if I look at these, this is neutral, so it could be either an acid or a base, but this one's negative, so therefore this one's going to be my base, and this is going to be my acid. And this time you only have to identify the acid and the base on the left-hand side. Going to this next one. Again, this one is negative and this one is neutral. So therefore this one is going to be my base and this one's going to be my acid. And for the last one here, this one's negative, so therefore it is going to be my base and this one's going to be my acid. I did not find an example. Sometimes you will see them drawn out as being NH3, so it's kind of a modified form, and it shows you the fact that the two dots or the colon there means the fact that there's a lone pair plus, I don't know, let's just say H plus goes to form NH4 plus. So in this case, if it has a lone pair shown, this is going to be my base, but also because this one is positive, it's going to be my acid. So sometimes it will be, if you have two neutral species, typically what is done is that one of the species will have a negative charge there. And I'm actually going to go to the book. These did not come from the book, but I know that there's an example of what I want in the book. So if I look at number 38 in the book, now they do it as drawings. I'm not going to be able to do it as a drawing. So it's AlCl3 plus that NH3. And I would draw it as having that with a lone pair. And so again, this is my acid and this is my base. They're both neutral, so I can't tell it from there. But because of the fact that there was a lone pair given, that's going to make it as my base there. Another example is from number 41, where I have Br3 plus AsH3. Again, these are both neutral species. This one gives me the whole reaction, the other one didn't, as being Br3 boron bond AsH3. What I didn't draw over, I didn't finish that over here, is this has a lone pair. So they're both neutral, so I can't tell by looking at these, but because this one has a lone pair, this one makes this one base, and this one an acid. And that's the end of this video.